All right, well, good afternoon, everyone. My name is Jagan Seshadri. I'm a senior product owner with SSI. Thanks for coming to the presentation, the first of two that I'm giving this afternoon. The title starts with hull effectivity, but I'm going to start with change management, because really that's the theme of the talk, and because I believe change management is a real critical problem with shipyards and design houses these days. So before talking about change management, we first should talk about the nature of these changes. So some thoughts about change. Change can be easy. Change can be hard. And for those of you who have been designing ships, you know, the smaller ships that are designed by smaller teams, whose work is done sequentially and whose changes are more or less isolated, I think you'd all agree that falls into kind of the easier change side of things. And you undoubtedly have processes that more than adequately handle that change and tracking it. However, and so I'm going to just denote that by a small ship, let's say. But change can also be hard. What if you have a large ship, or a larger team, a growing team, distributed team, concurrent work, and widespread changes? Well, I'm going to denote that by, you know, a larger vessel. And you say, well, look, maybe I'm only dealing with smaller ships. Thank you very much. I've got it under control. Well, change can be deceptive, especially when you're dealing with a series of ships, which is happening more and more these days. So change is easy, as we just discussed, but it can become hard. So if you have a series of small ships, again, you have more teams, because you know the first hull might start at a certain time, and then before it's complete, you might be already started on the second hull, and so there's this overlap. You're not done the first, but you've already started the second, and so forth. Concurrent work, obviously, and you can have widespread changes, but in a different way than with the large ships. In this case, think that you have an isolated change on one hull, but now you have to track that change among multiple hulls in a series, so it's widespread across hulls. So the nature of the change is different, but nonetheless, these complexities make it hard to track, hard to manage, harder to communicate. So I'm going to denote that by a series of ships. So it can be easy, it can be hard. You might think it's starting off easy and then it gets hard, and so that's why I'm talking about this topic. So let's maybe bring it closer to home with relating it to workflows. So imagine that you've not yet released any designs yet, you're still working on them. So I'm calling this the initial design workflow for a single hull. We don't need a whole lot of management. You know, people have freedom to make their designs, do some checks, make some changes. It's not very heavily burdened with any process. So for instance, you'll start by modeling a block. You may do some clash detection, find a mistake or a collision, make a change to the block, do a final check. Okay, it looks good. You release the block, stamp it with revision A, give it to planning, give it to production. So far so good. Now let's say that a number of blocks in the ship have been designed, and that's denoted by the coloring, and somebody finds a problem. So now you have a late change. So I'm going to show that late change by this triangle happening in that part of the ship. Okay, so we already released the drawings, we've released the work downstream. So now we have to manage this a bit more carefully. So we have really an engineering change order that has to be kicked off, in which we track the changes to the block. And so this is something I'm going to be talking about more. I'm calling this the triangle change. In this case, we need an access opening. And so this is really the nature of the change. You have a plate that needs to be changed. We're going to have to update the bill of materials and some properties, and also production drawings. You might have to redo some assembly drawings, perhaps an S drawing, a model drawing. So there's a lot more to track when it's a post-release change. But nonetheless, you do it, you do some clash detection, you do a final check again, you're good. You release the block this time as Rev B, which supersedes Rev A. And again, so far so good with a single hull. So now we're going to up the stakes a bit and go to multi-hull. So same idea. In the initial design workflow, before you've released anything, you still have to manage it more than with a single hull. Let's see if it's advancing here. It looks like it's stuck. Yeah. There we go. So as before, for hull 1, the process is as you'd expect it. For hull 2, now we obviously, in a series of ships, we want to reuse design. So we want to reuse the block, do some clash detection. There might be a variation in the second ship. So maybe that change pertains to the hull 2 alone. Maybe it pertains to hull 2 and hull 1, so you have to retroactively make the change in hull 1. So already you can see there's a lot more tracking and a lot more questions that have to be answered carefully and communicated carefully. So now we up the stakes even further. Let's say that this isn't leading up to release. We have released the design documents, we have released the production drawings, and again, you're having to track this with engineering change orders and more formal processes. So some considerations, we talked about the triangle change before, but now I'm going to talk about that square change. So what's the applicability? And that's what we're calling the hull effectivity. So the square change does not affect hull 1, but it does affect hull 2 and hull 3. And I put a little asterisk after hull 3 because hull 3 is a bit different. It's a variant of the ship and it needs some supplemental changes over and above the changes that we're sharing from hull 2. So now we need to be very clear about what the nature of change is, and we need to be very clear that we have tasks for this so that the people doing the work know what to do, know what supplemental stuff to do, know what not to do. Don't touch hull 1, for example. We need to be very clear with these things. And it has a downstream impact on planning, procurement, and construction. So change management, I've tried to present it in terms of workflows that you're familiar with. How SSI is going about solving this? Well, we really want to encourage the reuse of existing modeling work. We understand you'll have to incorporate changes and improvements in follow-on ships. And while doing this, we want to provide a great user experience, so it's intuitive and easy. So how has this been handled in ShipConstructor to date? And one of the ways of doing it is, let's say you have 2 hulls. You could have your product hierarchy and a bunch of blocks associated with hull 1 underneath that product hierarchy. You can create a second product hierarchy and have the blocks for that hull associated with the second product hierarchy. All the blocks are within a single ShipConstructor project, so you can kind of track things that way. The other option that you can do today is you have your base vessel, your hull 1, let's say, and you make copies of that project, hull 2, hull 3. And then you can use our workshare technologies to share the changes. Workshare design for sharing entire blocks, and workshare model for sharing parts. But SSI has a new approach for design reuse, and introducing workshare transfer. This is going to be coming out in the next release of ShipConstructor. And with workshare transfer, the idea is for design reuse, for sharing designs and sharing parts and sharing changes among hulls. So we have transfer parts, transfer production, in other words, production drawings, and also transfer logical containers among hulls. So your product hierarchies, your assemblies, your systems. So all this new technology is really meant to support this change management theme that I'm talking about. Okay, so let's get into workshare transfer of parts. So there are 3 ways to transfer parts. One is by selection. You just simply click in the drawing and it'll pick the part and you can go transfer that part to another project. Also by load criteria, so there might be certain ways you want to query your database, query your project. Say I want parts from this assembly, let's say, and you can gather them up that way for transfer. But also I was mentioning with teams and the importance of tracking tasks. You can transfer by tasks. Maybe somebody makes their change in hull 1. They make their engineering change order changes in hull 1. They know that this change is going to have to be propagated to hulls 2, 3, and so on. So you can track it as your ECO change and then run it forward. So that's very, very powerful. This triangle change that I talked about, I said this is an access opening. So here we've cut out an access opening and we've added some stiffeners to keep the structural integrity. And we want to transfer that change from hull 1 across to hull 2. So let's again talk about doing that as a task. So I'm going to call this task the triangle change. That's where we're adding this access opening. It's going to affect hulls 2 and 3. And like I said, we have a plate that needs to be changed. We have a nest drawing that needs to be changed because they might not have cut any of the plates yet for hulls 2 or 3. So you want to correct the nest before that cutting begins. Otherwise, you're just propagating a mistake. So that'll have to change. The assembly drawings, as it rolls up the hierarchy, they'll have to change. The model drawing where I made the initial design change, frame 65 in this example, that will have to change. So the way you would go about it, and I'm going to change the, instead of talking about an access opening, I'm going to talk about a piping change just to mix it up. So the way you do it is, let's say there's a piping change that has to happen, and you create a task for that. In this case, I'm going to call it move pipes. So you select your task, then you go about creating, modifying, deleting parts. And in this case, we're just modifying some parts, moving some spools around to make room for something or to avoid a clash. And then you do that work, and then you pick which project am I going to transfer this change to. I'm starting off in hull 1, my source project. I maybe want to transfer it to hull 2, my destination project. And so you pick that project, and you get a little summary. In this case, it's saying no items have been added, no items have been deleted, but 27 items have been updated. And you say, my goodness, I didn't think I had so many. Let's just click on that and see what the details are. And that's optional to click in the details, but it's nice to have. You can see a bunch of elbows, a bunch of pipes, and a bunch of connections changed their locations. Okay, that sounds like what I did. Good. Now we continue the transfer over, and now you can see the change to the layout of the pipes has been moved between projects, and that's exactly what you wanted to do. So work-share transfer lets you do that. Similarly, production drawings can be transferred. So the drawings that we support transfer for right now are spool drawings, assembly, arrangement, product hierarchy, pipe support construction, marine drafting, and output drawings. So same idea there. So, right. Now I'm going to talk about managing change with Shipbuilding PLM, and this is something you might not have heard of Shipbuilding PLM. I know Nick was just talking about Digital Hub and EnterprisePlatform. Well, Shipbuilding PLM is really our future vision, and we're working toward it. The idea is change can be hard, and tracking it is very important, and communicating it is very important. And so we've partnered with a company in North America called Eris that lets you see all these changes in one spot. You can query it. It's great for engineering teams. It's great for planning teams, project management. It sits next to ShipConstructor, and it basically shows you what's happened. So it's our tracking system, for uniting the entire workflow, your entire ecosystem, as Nick put it. So we just talked about work-share transfer, which is in ShipConstructor, but managing this, tracking it over time, that's where we're going to be putting this into Shipbuilding PLM. And so without getting into Shipbuilding PLM, and I'll be talking about its precursor, the Digital Hub, on Wednesday, and Dennis will be talking more about this whole initiative later this afternoon. But I'm going to talk about how to track a hull effectivity change using Shipbuilding PLM, using tasks, and using work-share transfer. So again, imagine that you've got a sister ship, a series of ships. You've released the work for hull 1. You've found a mistake, or you need to do a change. So you need to start an engineering change order. Okay, and hull 1 is at the top. So the first task is I need to make that change to hull 1, because that's where I found the problem. That's where I need to address it. But I know that this problem is going to come again, unless I fix it now, for the other hulls. So I'm going to make another task where I use work-share transfer to transfer those changes from hulls 1 to hull 2. And another task again to transfer that change from hull 1 to hull 3. So now all the designs should be up to date. and we won't have to do rework when it comes time to building hulls 2 and 3. Now, this part talks about how do you track that change into our shipbuilding PLM system. So basically, shipbuilding PLM has loaded up the current design, but now we're coming in with the change. We need to update that system to track the change and track where it applies. So we query ShipConstructor using EnterprisePlatform, and it gets those changes from hulls 1, 2, and 3, converts them into a format that our shipbuilding PLM can record. So again, it's the same change as before, but it's affecting 3 hulls, not just 1. And we push that back in to our shipbuilding PLM. So now planning can see it in there. Project management can see what's happening. The engineering teams can see what's happening. And basically anyone can see it. They don't have to be ShipConstructor users. So we update the shipbuilding PLM, we close out the engineering change order, and we re-release those blocks. So that's the overall change management vision that we have with hull effectivity and change management. So we'd like to think of it as solving what we think is the hardest problem in shipbuilding. It's change. It's tracking change. It's tracking hard change. And I've showed you this afternoon how we're doing it with work share transfer and how it will be pulled into our shipbuilding PLM system of record. Really, the takeaways are we want to reuse designs and we want to reuse changes. We can use work share transfer to transfer those items among hulls. And we want to manage change using ShipConstructor tasks and the shipbuilding PLM. And so we've been putting these technologies to work, but to solve real-world problems. So that concludes my presentation on hull effectivity and change management. Thank you.